Today's speaker is Susan Loeb, who is an upland hardwood ecology and management with the Upland Hardwood Ecology and Management Research Unit there at Clemson, South Carolina. And so with that, I'm going to turn it over to Susan.
Okay, thank you very much. Can everybody hear me all right? I assume you'll let Bob know if you can't. Thank you all for joining in, and I hope I can provide you with some of the information that you might need to help you in terms of conserving and managing bat populations in the eastern United States. I have a lot of material to cover, and I had to get rid of a lot of material. So if you have questions either about what I have covered or what I didn't cover, please feel free to email me, and my email address is at the bottom of this slide. So what I'd like to do today is, first of all, convince you that bats are really important and that you need to take care in terms of managing and conserving them. And even if I don't convince you that they're important, that for some of you, you may need to manage or conserve them just because of their legal status. Then I want to go over some of the threats that are impacting our bats and why it is so critical that we take time to consider how we need to go about managing and conserving these important species. Then talk a little bit using some research that we've done as well as some others to give you a few things that possibly that you as a manager on the ground can do to help our bat populations. And then finally, I want to talk at the very end about a monitoring program that we are developing as part of the white nose response team, but it is much greater than white nose. So I'll talk about that at the end. So in terms of the importance of bats, they are extremely important, and in fact in 2011 and 2012 the UN designated that year as the Year of the Bat. Still getting my advancing correctly. Most people start off in terms of talking about the importance of bats in terms of their economic and their ecological importance, and I'm going to get to that. But I also want to start off with talking about how important they are just in terms of what they represent in terms of biodiversity. They are the second most diverse or numerous group of mammals. There are approximately 1,240 species of bats. They come in a variety of sizes and shapes, anywhere from about 3 grams, which is the smallest mammal on Earth, up to about 4 kilograms, which is about a little over 2 pounds. All sorts of colors and shapes and ornaments. They feed on everything from insects to fruit to nectar to blood to fish, birds, and other mammals. And the thing is that we are not done discovering new bat species. This is a species that had been found in the southern Sudan in the early part of the 20th century. They thought it had gone extinct. It was rediscovered, and it turns out it's a new genus. So there's still a lot that we need to learn about bats, and we need to keep them around to learn that. Getting into their ecological and economic importance, I said there are about 1,240 species of bats worldwide. About 70% of those are out there eating insects. A lot of those are eating, some of those may be eating those mosquitoes that are bothering you, but they're eating a lot of other things. They're eating beetles, they're eating Lepidoptera, they're eating a whole variety of insects. And here in the United States, 95% of our bats are eating insects. The only bats that feed on nectar or pollen are down in the desert Southwest. It's very difficult to quantify the actual impact of this insect eating by bats. There have been a few studies done in Central America. This was a study where they looked at islands of natural forest as well as pine plantations. And they were able to exclude bats and exclude birds and compare the amount of leaf damage in those areas where they excluded bats and birds compared to where they didn't. And what you can see is that when bats and birds are present, there is significantly lower leaf damage to these trees. So, and there are a few other studies that have demonstrated that having bats and birds can decrease the amount of leaf damage on tropical systems. This was some results from a study that was done in south central Texas, an 8-county area that's a very important agricultural area. They grow a lot of corn and a lot of cotton, in this area. And they tried to quantify the impacts of Brazilian free-tailed bats on the insects in that 8-county area. Now, bats in this area, you can get several million bats congregating in a cave. They fly out across the landscape and forage over these agricultural crops. They estimated, based on reduced damage to the crops, reduced pesticide costs due to the bats eating the insects, and the reduced social costs, i.e. to our health, that in this 8-county area alone, these bats were providing anywhere from $120,000 of pesticide control services per year up to $1.7 million worth of pest control services per year. Now, Justin Boyles and his collaborators took those data and extrapolated them across the United States, or at least the lower 48. And based on the agriculture in each colony and somewhat some estimates of bat populations, they estimated that on average, bats are providing about $23 billion worth of pest control services per year in the lower 48. So that could be very significant. If we start to lose bats, that could have some economic impacts. Bats don't just eat insects, as I mentioned, and they have lots of other important ecological and economic services. In the tropics and subtropics, a number of those bats are pollinators. One of the species that we have in our desert southwest, a couple of our species actually pollinate the agave plant, from which we get tequila. And tequila is a very important economic product of Mexico. They also pollinate a number of other agricultural products throughout the tropics and subtropics. A number of the bats are also fruit eaters. They eat the fruit, they deposit those seeds. Because these bats can fly over long distances, they can disperse those seeds well across the landscape. And in some areas they can do this. This can be very important, again, for some agricultural fruit crops as well as forest regeneration. They also may be very important in terms of nutrient cycling. So they're eating all these insects out on the landscape. They come back to their roosts. They deposit the byproducts of those insects in their guano. So, for example, if you get a colony of little brown bats or northern long-eared bats, particularly northern long-eared bats or Indiana bats, they oftentimes will roost in snags between the bark and the bole. You'll get 20 to over 100 bats in there during the day, and they're depositing their guano at the base of the tree. That is providing excellent fertilizer. So once that snag falls down and there's regeneration, the forest floor has already been fertilized by these bats. In some areas, particularly in the southwest, they are becoming a tourist attraction. So if you've ever go to Austin, Texas, visit the Congress Avenue Bridge, and there will be hundreds of people out there every evening during the summer watching the emergence of these bats. Carlsbad Cavern is another place. This brings in money to Austin as well as other areas where people go to see these amazing emergences. They're also very important in some medical research. Vampire bats have a compound in their saliva that is an anticoagulant, and it's been found that that anticoagulant is a far better treatment for strokes than other anticoagulants that have been tested. There are also bats some of our bats can live to be over 30 years old. For such a small animal, that's incredibly old, and so they are being used now in aging and senescence studies. They found that possibly some antioxidants in their system allow them to live that old. So again, bats may be helping you live a longer life. So even if you don't care about the importance of bats, you may need to be concerned about bats purely because of their legal status. In the eastern United States, we have 4 federally listed endangered species. These are the gray bat, the Indiana bat, and then 2 subspecies of the Townsend's big-eared bat, the Virginia big-eared bat, and the Ozark big-eared bat. We also have 1 proposed endangered species. This is Florida bonneted bat. It's only found in, I think, about 4 counties in southern Florida, so it's not going to have an impact on many people's management. But there are also 3 species that are currently under review by the Fish and Wildlife Service. These are the northern long-eared bat, the little brown bat, and the small-footed bat. So the Fish and Wildlife Service is in the process of determining whether these will be listed as threatened or endangered, and they will be coming out with those decisions towards the end of September. So that could have an impact in terms of your management if these species do become listed as endangered. So what are the things that are causing the endangered status of these bats that I've already talked about, as well as some other species? And when I think about the threats that have impacted bats, I sort of think about it in terms of my career studying bats. When I started studying bats in 1999-2000, we were dealing with one set of threats. Since about the year 2003, we've been dealing with a whole another set of threats. So I'm just going to first of all talk about these, what I call the 20th century threats, or the chronic threats. And these have not gone away, so we are still dealing with these. Like most species, habitat loss and fragmentation is a major impact on bat populations. In the eastern United States, most of our bats rely on forests for at least part of their life cycle. And for most part, they are relying on mature forests. So when we lose forest, we are losing roosting habitat and we are losing foraging habitat. And even though bats can fly, a lot of our bats do not like flying over large open expanses. So fragmentation can prevent them from moving from one patch of forest to another. Another chronic threat to bats is cave and mine disturbance and destruction. A number of our species hibernate in caves and mines during the winter. They store up a few grams of fat, and they use that fat throughout the winter. They don't, for the most part, do not feed. If all goes well and they have a normal hibernation cycle, by the end of the winter, they've used up that fat, but they're okay. But if you go in there and you disturb the bats, they wake up more than they normally do. They will use that body fat, and they may not be able to make it through the winter. Also, for some reason, some people just like to go in and destroy caves and also destroy the bats in those caves. And cave and mine disturbance and destruction are probably the major factors leading to the endangered status of both the gray bat and the Indiana bat. Other 20th century and chronic threats that we are still dealing with are such things as toxicants and pollutants. Almost all bats must drink free water, so they don't get their water simply from their food. They have to drink from streams and ponds. So they must have clean water. And as I mentioned, some of these bats can live for a very long time, so that they can accumulate these toxicants over their lifespan, and it could build up to such a toxic level. Whereas a mouse that only lives, a year or so probably doesn't have time to really build up those high, heavy toxicant loads. So we're talking things like pesticides and heavy metal. Another source of pollution might be light pollution. Some bats actually prefer light. Oftentimes you'll see bats flying at street lamps, foraging on the moths that accumulate there. But there are some bat species that avoid lights, and some recent studies in Europe have found that they particularly avoid LED lights, and it seems that more and more cities and towns are going to LED lights as opposed to the more traditional lights. Roads and traffic may also be a problem. Probably not so much. Sometimes bats are killed by cars, but some bats just avoid high traffic roads. So this could be, again, a problem in terms of fragmentation. Getting on to our 21st century threats, these are the ones that have just sort of emerged over the last 10 years. The first one is wind energy development. People were going out and surveying these wind energy farms, looking mostly for birds. And particularly in the eastern United States, they were finding far more bats than they expected. And in the eastern United States, they were finding more bats than they were finding birds. So how big of an impact is this? We're not sure. Most of the bats, not all, but most of the bats that are killed by wind turbines are what we call our migrating species. These are bats such as the red bat, the hoary bat, and the silver-haired bat. These bats do not hibernate in caves and mines. Instead, they migrate south for the winter. And most of the mortality is occurring during that fall migration, so the end of August and throughout September. For some reason, they are colliding with those turbines. We're not sure why. They may, in fact, even be attracted to those turbines. They also may be experiencing barotrauma. So there's a pressure gradient between one side of the turbine and another. As they pass through that pressure gradient, they are essentially experiencing the bends. And so they're having internal damage, they're having damage to their internal organs. So again, it's very difficult to count this. People are out there actually picking up dead bats at the base of turbines, and from that they're able to estimate how many bats are killed. So Tom Coons in 2007 estimated that by 2020, anywhere from about 33,000 to 60,000 bats would be killed in the mid-Atlantic region alone per year. And a recent estimate came out by Sean Smallwood that estimated that in the year 2012, about 880,000 bats were killed by wind turbines. The difficulty is, and I'll talk about this later on, is that we don't know how many red bats or hoary bats or silver-haired bats are out there. So it's difficult to say how much of an impact this is going to be on our bat populations. But one might expect if this is a chronic source of mortality on top of other sources of mortality, it could be important. And I assume most of you have heard about white-nose syndrome. Again, this is something that was not on the horizon 10 years ago. White-nose syndrome is a disease caused by a cold-loving fungus. The fungus is Geomyces destructans. It invades the tissues of the bats, particularly their wings. It causes them to arouse frequently during their hibernation, and so they expend all of their energy reserves and they die. It was first found in Albany, New York in the year 2006-2007. Since then, it has spread, and it is now found in 22 states and 5 Canadian provinces. It has caused mortality or disease in 6 species and has been found on additional 2 or 3 other species. In terms of its effects on populations, it's been estimated that at least 5 to 6 million bats have died due to white-nose syndrome since 2006 in the eastern United States. and that we are looking at mortality in some species as high as 90 to 98%, those for little brown and northern long-eared bats, and 70 to 75% in species such as Indiana bats, which are already endangered, and the tricolored bat. The good news on the horizon may be that species such as the big brown bat may not be impacted much by this disease at all. So what is this going to mean to our bat populations in the future? This is a model that was developed by Wade and Thogmartin and his cooperators. And what you can see is that in about 2010, there were a little over, estimated over 500,000 Indiana bats. His models predict that in about 10 years, populations will be very low. If the bats are able to acquire an immunity to this disease, they may be able to rebound somewhat, but even by 2060, they would not be at the level that they are today. If they are not able to rebound from this acquired immunity to this disease, then it is very likely that they will go extinct, at least locally in many areas, and be at very low levels other places. This is another model based on pre- and post-white-nose populations of little brown bats, and Winifred Frick and her cooperators estimated that little brown bats in the northeastern United States would go locally extinct within the next 10 to 15 years. Climate change is another factor. We don't know exactly how climate change is going to impact bats. Some species, maybe we will be looking at range contractions. Other species that may be limited by cold temperatures, we may be seeing range expansion. So it could be that we start seeing species that where we had never seen them before. For example, the three-tailed bat seems to be moving north. We don't know whether that's due to climate change or something else, but those species definitely is moving north. This is a model that I and my technician Eric Winters developed on Indiana bat distributions in relationship to climate change. This graph shows you what we have, the current distribution based on current climate. And what you can see is that the majority of the maternity range for Indiana bats is in the Midwestern United States now, and that's what the models suggest. However, if you predict future climates, the models suggest that the Midwestern United States will no longer be suitable, climatically suitable for Indiana bats, and the most climatically suitable area will be in the northeastern United States and the southern Appalachians. Unfortunately, those are the areas that have been hardest hit by white nose syndrome. Another threat potentially on the horizon is fracking. Again, I mentioned that white nose syndrome, clean water is critical for bats, and we do know that fossil fuel extraction can have an impact on the water supply. So I painted a pretty ugly picture here, and you might want to just say give up and go away, because bats are just dying everywhere. I don't want that to leave that impression. I want to give you at least some things that you can do to help foster bat populations out on the landscape, that maybe we can help these bat populations survive until they can recover. So the first thing we need to do is figure out what bats require, figure out how you can provide those requirements, and then eliminate or decrease some of those threats. I'm not going to be able to go over number 3, but hopefully talk a little bit about requirements and how you can provide those. So like any animal, bats need a place to live, and they all roost somewhere during the day, and some of them will also roost somewhere at night. They need a place to eat, and they need food in that place to eat. And they need, as I mentioned, easy access to clean water. So in terms of roosting, we usually break up our eastern bats into two groups. They don't all fit into those groups really nicely, but the first group is our cave bats. And these are bats that hibernate in caves and mines during the winter. Some of the bats, like gray bats and Virginia big-eared bats, will then move to warm caves during the summer where they have their young. Other species, like northern long-eared bats or Indiana bats, leave those caves in about April. They disperse across the landscape, and they find trees, primarily snags, out on the landscape, which is where they have their young. Our other group of bats are our migrators, or our tree bats. These are species that primarily just hang up in the foliage during the summer, and a clump of hardwood leaves, a clump of pine leaves, depending on the species. They migrate south during the winter. During the winter, again, they'll hang up in foliage or in shrubs, or even get down under the litter, particularly when it's particularly cold. So some of the management strategies in terms of live trees. One of the general patterns that we see in terms of trees that bats select in terms of live trees is they tend to select the larger trees out on the landscape. These are just two examples. One is from Roger Perry's work down in the Ouachita Mountains on red bats, and you see that these bats are selecting the largest diameter and the larger, taller trees out on the landscape. Another example is some Raffenest big-eared bats in Congaree National Park. Again, the bats are selecting the larger diameter trees, in this case not so much in terms of height. So what does that mean? That means if you are managing live trees for either your foliage roosters or bats that get into cavities in live trees, what we want to do is manage for those larger trees. The larger the tree, the more likely the bat is to use them. These are usually found in mature forests, and because some of these species will use, like Raffenest big-eared bats or southeastern myotis, like big hollow trees, even though they're alive, maintaining those damaged trees that will have create those cavities will also provide roosting habitat in the future. And we also, in terms of those damaged trees, may consider some artificial cavities. Snags are also used by a lot of our species, northern long-eared bats, Indiana bats. And again, our general pattern that we see, this is some work that Joy O'Keefe and I have done up in the southern Appalachians on Indiana bats. Again, the general pattern you see with Indiana bats and most of our species is they tend to pick the larger snags out on the landscape. They also tend to pick snags that get solar exposure. This allows them to passively warm, particularly at the late part of the day, so they don't have to use their own energy. So in terms of maintaining snags, what we want to do is maintain the largest snags out on the landscape. I understand that this can be a safety consideration, but if a snag is safe to save, again, the larger the better. Saving small snags is not horrible because they will be used. The other thing is bats tend to like snags that are in clusters over an isolated snag on the landscape. So if you have a choice of saving 10 snags, if they're all in a group, go with that as opposed to 10 scattered snags out on the landscape. And again, we may want to consider creating snags out there. Now, I want to talk a little bit about prescribed fire effects on roosting habitat because prescribed fire is a very important management tool. It's a very important restoration tool. And the problem is it can have some impact on roosting habitat of bats. So first of all, I mentioned species such as red bats and Seminole bats will oftentimes get down into the litter when they're roosting during the winter. And many of you may have already had the experience of seeing bats flying out when you're putting out your prescribed burns. Red bats are one of these that are being heavily impacted by wind turbines, so we are concerned about their populations. So some studies done in Missouri and South Carolina have found that come up with some recommendations based on the behavior of the bats. And basically, bats are more likely to respond or will respond more quickly to the smell and the sound of a fire the warmer it is. And also if the wind speed is greater, because the smell of the smoke gets to them. They're also more likely to roost in trees as opposed to the litter the warmer it is. So the recommendation is, if you can, and you are concerned about bats in your winter burns, then at the time of the burn, you wait till it gets to be at least 10 degrees Fahrenheit or 10 degrees centigrade or 50 degrees Fahrenheit before you start your burn. What about prescribed effects, fire effects on snags? Does prescribed fire destroy snags, or does it create snags? Again, Joy O'Keefe and I have been working on this for the last several years in Great Smoky Mountain National Park and the Cherokee and Nantahala National Forests. We've been tracking snags for several years, for 1 year pre-burn and several years post-burn, and our preliminary results, and I stress preliminary, is that for the most part for our warmer burns, we are losing the larger snags but creating small snags. As I mentioned, we are continuing to follow these snags. That may change. Results from other studies have found, however, that bats do select roost in areas that have been burned. So examples from evening bats and northern long-eared bats. This may be because the prescribed bird opens the canopy and it increases the solar radiation. The bats can use the sun to passively warm. So in terms of fire effects and some recommendations, we do know that prescribed fire benefits in the long term bat habitat, bat roosting habitat. In the short term, it may have some short-term direct effects. So we recommend avoiding post-emergence burns. So when they first come out of the hibernacula, they may be depleted with their fat reserves, and they are more likely to go into torpor. So that may be a problem, and also avoiding late pregnancy and early lactation. It's harder for the females to move the young at that time. Very briefly, in terms of foraging habitat, we have a variety of bats out there. They all don't use the same types of foraging habitat. Some species, like northern long-eared bats, like cluttered habitat. Other species, such as hoary bats, like the more open habitat. So we need to provide a variety of habitats: cluttered habitat, which is more dense forest, open habitat, and then intermediate. So things like mature forest, openings and edges. A number of our intermediate species like to forage along edges, and also providing canopy gaps. So what kinds of management activities can we do to increase the suitability of foraging habitat? This is just one example of a study that we did in Clemson, South Carolina, and there are a number of other studies out there that show that doing prescribed burning in, particularly in second growth forests, doing such things as prescribed burning and thinning will decrease the clutter, and at best will increase the foraging habitat or increase the suitability for foraging for bats. And if nothing else, it is a neutral effect. So burning and thinning can be either neutral or have a very positive effect on bat habitat use. This is just some other data looking at different types of habitats that they use in the Nantahala National Forest. And again, open habitats, so wildlife openings, forest roads, even some of our small clutter-adapted species are using these areas. So creating some small patches of early successional habitat may be very beneficial for foraging bats. So just again to sort of summarize, maintain mature forests for those species that like those more cluttered habitat. In other areas, particularly those very, very dense second growth forests, considering doing some thinning and prescribed burning, create or maintain some small gaps, and maintain some early successional habitat and edges. Okay, just very briefly in terms of riparian habitats, bats like these habitats. They can get water. It's also oftentimes a very good source of insects. And oftentimes there are large trees there for roosting. So it's important that those corridors remain open so that bats can actually have access to the water, so really rhododendron clogged streams are not used. And again, maintaining those large trees along the stream, that provides them with roosting habitat and also provides them with an area that they can escape if predators come along, such as hawks and owls. And drinking water, I mentioned it's critical for a number of our species. Just the water itself, it may be an important source of calcium and rich in insect prey. And if you are interested, this is an excellent publication produced by Tom, I can't pronounce his name, on the Daniel Boone National Forest. And it's a great for providing wetland, constructed ponds in upland forest. And this may be increasingly important for climate change. So finally, I want to talk about monitoring. And as a manager, you know how critical monitoring is. You need to do that to determine the effectiveness of your management, but we also need to know a lot about our bat populations in order to manage them on a long-term landscape scale effectively. So first of all, we have our threatened bats. We need to know whether those threatened bats are continuing to decline, or maybe are they recovering. There are other species out there that we have not been monitoring, and we don't know what's going on with their populations. And they may be declining, they may not be, but we need an early warning system to know whether they are declining and what may be causing that decline. Are bat population distributions changing? This is a critical question in terms of understanding the impacts of climate change on bat populations. And then, as I mentioned, are we doing a good job with our management? Are they responding to our management? About, let's see, a couple of years ago, some of us, as part of the White Nose Response team, the Conservation and Recovery Working Group, began to develop a, first of all, national bat monitoring program. It has now become an international effort because we share a number of species with both Canada and Mexico. This is an interagency effort. We've got members on our team from Forest Service, Park Service, USGS, Fish and Wildlife Service, DOD, Canada, Mexico, and this is truly an interagency international effort. We are trying to develop a sampling protocol that can be used at the site level. So if you want to monitor at your district or state forest or whatever, but that the data collected at that local level can feed into a national effort so that we can look at larger scale trends in bat populations, for example, at the state level or the regional level, or even for some species at the continental level. The methods that we are will be incorporated into this monitoring program are colony counts, so primarily hibernacula counts, but also maternity colony counts as well. And acoustic sampling, so using bat detectors to quantify, get estimates of either relative abundance or activity of bats. So this is either putting a bat detector on a vehicle, driving down the road for about 30 miles and recording all the bats along that road, or putting bat detectors out at stationary points for several nights. This is our sampling grid as it stands right now. It's a 50 square kilometer grid that is put right here just on the U.S. And that those 50 by 50 kilometer grid cells are divided into 25 10 by 10 square kilometer cells. And we will be using what's called a spatially balanced design. And this is a relatively flexible design. It is still a random sample, but it is flexible in case you can't get to an area because it's closed off. Or, on the other hand, if you want to oversample, if you want to concentrate, say, on national forest lands or Park Service lands or state lands, you can incorporate that sampling inclusion probability into the analysis so that it is statistically robust, and that is what we are working towards. This is just an example of a transect that we are running. We're doing a pilot study this summer. This is our 27-mile transect, and it goes across about 3 of those 10 by 10 kilometer grids. And we are also doing point sampling at the same time because we're trying to calibrate our point sampling with our transect. What we are hoping in the future is when people adopt the sampling protocol that they will be able to do both the transects and the points sampling. If they can only do point sampling because there are no roads in their area, that's fine. If they can only do transects because there's so much private land or it's just easier to do the driving transects, that will work as well. So just to give you our vision of where we see NABat going, we see this as a long-term commitment to bat monitoring, just as there is for bird monitoring, there is now for amphibian and reptile monitoring. We will be having hopefully a national or international coordinator, a statistical analyst, so that we can analyze these data on an annual and multi-annual basis. We already have a database set up. It is being developed in conjunction with the monitoring program so that the two will work very closely together. It's a bat population data project. It's housed by USGS Fort Collins. You can go there and search it now for data that are already in there, but you can also will be able to get access to submit your own data. And we will be having products. So again, the point of this is to provide managers and policymakers with the information they need to manage and conserve bats. So with that, hopefully we have a little bit of time for some questions.
Thank you, Susan. We do have time for questions, and actually there's been 1 or 2 questions, I believe, typed in already. Let me just scroll through the chat here to make sure I'm not missing anything. Several people have asked about the, is this being recorded? It is, and you'll be able to find it up on forestrywebinars.net. So for that information. So here's one from Shannon McGee. In areas like Central Florida where we do not have large caves and caverns, I believe we have mainly tree bats. Is there any evidence that bat house programs in the urban-rural interface can make a difference in populations?
There are not a lot of data on the effectiveness of bat houses. We do know that bats do use bat houses. I know they've built some huge bat condos in Florida, and particularly areas I know like southeastern Myotis that do use caves in Florida. They have also tried to build bat houses for them as well. Again, particularly in areas where there may be conflicts between bats and humans, where bats are getting into houses, providing them with an alternate roost site that provides people the ability to exclude the bats from their houses, and that provides the bats with an alternate roost site so that they're not coming into conflict with humans. Because getting large aggregations of bats, particularly free-tailed bats, in your house is not a good thing.
That's true, especially if you're married to my wife. So the next question is from Hank, and he was wondering, how heavy did you say the largest bats get, and what size gaps do you suggest in mature forest?
Okay, the big bats are the fruit bats that you find in places like Australia and Africa, and they can get up to over 2 kilograms, so about 4 pounds. Have huge wingspans and just amazing bats. Gaps, the size of gaps, that is a really interesting question, and it's actually a study that we are just starting up on the Nantahala National Forest, where we are going to be looking at different size openings and how bats use those openings. And so can I answer that question in about 3 years?
So you're offering to do a follow-up webinar in 3 years. Great.
Right.
I'd love to hear that. Here's one of the things that I know that's going on here at NC State is there's researchers actually attaching GIS, GPS type transmitters to track bird migration. So there's a faculty member here that puts little transmitters on birds, and you can watch where they fly all over their migration patterns and stuff. Is there any research looking at that type of work, the migration patterns of bats and using that type of technology?
Right now, bats in the United States, our biggest bat gets to be about 30 grams. So a GIS transmitter is just way too large right now. They have used them on some of the fruit bats, and so that's amazing technology. When they get it small enough for us, that will be great. We do use radio transmitters to track bats, and we've found, particularly been able to locate maternity colonies, for example, of Indiana bats in Georgia and Alabama and Mississippi that we never knew were there by tracking them with planes with these radio transmitters. So some work is done with just traditional radio transmitters. The other technique that we use for looking at migration is stable isotope analysis. And we have done, as well as Paul Cryan, has done some work on stable isotope analysis to look at the range of migration. You can't, it's a much bigger, much larger area or error. So it's a little bit fuzzier, but that's one way to look at the range of migration in bats.
Okay, here's one question that's asking, when do you expect the monitoring program to be available to land managers? Okay,
we are drafting it as we speak. We have a group of people core group of people that have been working over the last year to do this, and we intend to draft it and in our workshop in November, hopefully try to finalize the protocol and then come out with something like a GPR or equivalent that will go out to land managers.
Okay. The next question is the NABat protocol is still under development, or can it or a draft be shared?
It is, as I mentioned, we're still working out the kinks. We're doing this pilot study this summer. You know, I'd be happy to talk to anybody about it. We're not keeping it secret at all, but we are, again, it's pretty much set, but we are working out the kinks, and we do know that it will be done adaptively. So if you have suggestions, concerns, please feel free to email me with either of those.
Okay, so here's a question on fungicide. They're wondering if the use of fungicide affects bats.
People have talked about using fungicides. You can't go into a cave and just broadcast fungicide, because caves are incredible ecosystems of themselves, and there are just an amazing number of fungi in there, as well as other species. There are a number of chemicals that are being tested to control geomyces destructants. Some of those are fungicides, some of those are like other bacteria that may be on bat skin normally that might help them fight off the infection, and some other volatiles. So people are definitely testing those. Again, it's a concern in terms of what the direct effect is on the bats themselves using these chemicals, as well as the other part of the cave ecosystem. We could do more testing in mines, and also some people are setting up these artificial bunkers, artificial hybridacula, and that's another way that we can do some of this testing.
So people are wondering if we expect nocturnal insectivores bird populations to increase if there's a decline in bat populations.
I don't know that. I guess the question would be whether the nocturnal insect availability is what is limiting those bird populations. And, you know, primarily out there, bats are the major. There are certainly birds out there. But that's an interesting question in terms of how the decline, you know, the loss of this possibly keystone species, because they are the major nocturnal predators of insects, what the loss of that species will mean to the entire community. So the insect community as well as other nocturnal predators out there. A very interesting question, and you know, a great one to start addressing.
Before we go on to the last couple questions, I just want to point out to everybody I've pushed out the URL which will launch your browser for the post survey. We ask that you complete this even if you're not participating to get the continuing education credits. If you're participating for the credits, after you complete the post survey, it will direct you to the quiz and a form that you can complete in order to get your continuing education credits. If you bear with the system, there was over 100 people on the webinar today, and so it will take a minute or so to load. If you do have trouble with it loading, I have posted the URL here in the chat window. Feel free to copy that and save it for later. So moving on to the next question is, somebody has a bat population living, some bats living under their porch, and they're fine with that, but they would like to be able to move them to a nearby bat house. And they were wondering how close does that bat house need to be to get them to, for the bats to move to it?
You know, bats are out there, they are flying, they know about alternate sites. And so the first thing that we like to do is, if you're going to exclude bats from your house, not do it during the time when the young are still dependent on the mother. And then it's always hit and miss when you put a bat house up. They may use it right away, or they may not. And they may know of another house out there, somebody else who has a place where they can live. So they may or may not go to your bat house. If you go to the Bat Conservation International website, www.batcon.org, they have some recommendations in terms of what types of bat houses you can use and where to place them. So you want to, usually, you want to put them facing southeast to southwest so that they get some of that warming. And depending on the species, they may either want to be at a forest edge or more out in the open.
Okay, so here's a question in reference to replacing natural roost trees for bats. Is there any work on artificial roost on public lands for those trees that have fallen over that are natural roosting trees?
There has been some work, particularly for raffinest-figured bats. They have come up with these bat towers, a number of different people, and they actually, after one of the hurricanes about 6 years ago, I forget which one, down in Mississippi. A lot of those bat roosts were lost, and they did try and put up some artificial roots for that species. That's one that likes big hollow tupelo and cypress trees and other big hollow trees. So that has been done. Also, yes, some people, I'm not sure in terms of creating snags, but that is something that can be done. And actually, there is Copperhead Consulting has come up with what they call Braden bark. And basically you can get a telephone pole and this bark, and bats, Indiana bats on Fort Knox have started using that. So there is work out there in terms of creating artificial roots.
Thank you. So last question. This one is pertaining to, from Marty. He is wondering, is there a national strategy to educate the general public and gain broad public support to conserve bats?
Yes, I think so. As part of the White-Nose response plan, there is a communications group, and a large part of their goal is to educate people of the importance of bats and transmit information about white-nose syndrome and what is occurring. There are also a number of other groups out there, Bat Conservation International, a number of other NGOs that are doing a wonderful job in terms of educating bats. And I think a lot of the agencies are also trying to get out the word that bats are really important for healthy ecosystems, and that we need to conserve bats. So, and I think one of the good things about the, and I didn't mention about the monitoring program, is that we hope to get a lot of citizen science involvement. So I think that too will help in terms of getting the public involved and concerned about bats.
Great. So at this time, I'd like to thank you, Susan, for all the time and energy you put in today's webinar. I'd like to remind everybody the webinar is being recorded and will be available by Monday on forestrywebinars.net. So if you have friends or colleagues that weren't able to participate in the webinar, they'll be able to view it there. So let's give Susan a big round of applause for helping out with presenting today's webinar.
All right.